Kami dari Group 5 ingin membentangkan lab Sains Material. Nama saya Muhammad Akmal bin Ismail, bernombor pendaftaran 11 DKM 19 F1046.
Nama saya Muhammad Nur Nizam bin Mansur, nombor matrik 11 DKM 19 F1043.
Saya Muhammad Ali Najmi bin Azmi, nombor matrik 11 DKM 19 F1052.
Saya Muhammad Nur Nizam bin Mansur, saya ingin membentangkan report bertajuk Metal Graphic Specimen Preparation. Okay, first kali objektif dia to determine the microstructure of metal alloy through the examination of specimen with a metallurgical microscope. Apparatus: metallographic cutter, rotary, pre-grinder, universal polisher, specimen, mounting press and metallurgical beach microscope. Okay, ini figures 1.0, equipment and apparatus for metallographic specimen preparation. Okay, ini teori dia. Metallographic is the study of the material microstructure, analysis of a material microstructure aids in determining if the material has been processed correctly and is therefore a critical step for determining producibility and for determining the factor of material failure. The basic step for proper metallographic specimen preparation methods: sectioning, mounting, grinding, polishing, etching, and microscope analysis. Procedure A. Sectioning. Number 1, sectioning is the removal of representation area from the parent piece. Number 2, cut the metal alloy into design dimension. Number 3, to cut clean and fast a bonded apparatus well must be matching to the cut of machine. Number 4, sufficient and proper cooling is essential to avoid wear during submerged cutting. B. Mounting. Number 1, specimen mounting primarily is for manipulation and eager protection during preparation. Number 2, compression mounting technique. Hot mounting is used to produce hard mount in a minimum amount of time. However, cool mounting technique after particular advantage when a specimen may be too delicate to withstand the pressure and heat involved in compression mounting. In the experiment, cool mounting technique is used. Number 3, mix the exposed resin and hardness by volume. Weight ratio of 5:1 accordingly. Leave the mounted specimen for curing in average temperature. C. Grinding. Number 1, the purpose of grinding is to remove deformation product during sectioning and provide the initial flat surface. Number 2, grind the specimen. After cutting on design covered rotation while pre-rotate grinder. Number 3, the size range of silicon carbide. This is 900 to 1400 grade. Number 4, spray distilled water has a coolant to prevent overheating of the specimen and flush away the surface removed product. D. Polishing. Number 1, the final polishing stage surface to remove any deformation zone result from grinding. Number 2, polish the specimen uniformly on rotation polishing cloth to obtain straight free surface. Number 3, spray the film of the orange water on the surface of specimen during polishing stage has the specimen media. etching. Number 1, the purpose of etching is to optically enhance microstructural features such as grain size and phase feature. Number 2, etch the polished specimen with the spherical etchant as listed below accordingly. Ni table 1.0, the chemical etchant. Ni result data. Okay, question 1. Why do we need to maintain the surface for specimen remain grinding? We need to maintain flat surface for the specimen during grinding because it is necessary for subsequent grinding and production stop. Number 2, question 2. What are the precautions that should be taken during the grinding stage? Number 1, safety glass must be weighed during grinding. Roman 2, never adjust the workpiece of work mounting device when the machine is operation. Roman 3, remove workpiece from grinding well before turning machine off. Question 3, why is it necessary to wash the specimen immediately after etching? It is important to wash the specimen after etching to stop the etching process from deforming the grain. Question 4. What is the function of the etching solution and the importance of use the correct concentration and time to relieve properties such as grain size, segregation, and the shape, size, and distribution of the faces and inclusion the present well after aspects such as mechanical deformation and thermal treatment may also be able to determine. Discussion. Metallography is important to determine the structure of a material. It helps to identify spatially distribution of the contribution inclusion of faces metallic alloy. Conclusion. Metallography consists of the study of the constitution and structure of metal and alloy. Incorrect technique in preparing a sample may result in the type microstructure and will most likely to smoother conclusion. Okay, done. Terima kasih.
Nama saya Muhammad Akmal bin Ismail, ingin membentangkan report 2 bertajuk Aqueous Hardness Test. Objective to determine the undetectation hardness of mild steel, brass, aluminium, etc. using Vickers hardness testing machine. Apparatus use Vickers hardness testing machine. Procedure type of inductor used is diamond cone inductor with square base pyramid shape. The saddle specimen is placed on a spotting table and the tie is adjusted by rotating hand wheel. Okay, 3. The use to be applied on a specimen is set by adjusting the knob. Okay, 4. The time up to but as to be applied for the specimen is adjusted. The base is applied for a period of 10 plus 0.15 second. Okay, 5. Apply the selected load by pressing the green button for 2 to 3 seconds until the red light glow. The image of the instrument will not be clearly visible. Screen measure the the length in x two direction. Observation, okay, ni observation dia, trial specimen, ni average design length, vehicle hardness, average trickle, 12 mistake 30, 0.2735, 0.269, 743, and 7.763.65, 756.10. Alright. Theory, the weakest hardness test was developed by R.L. Smith and Sandland in 1921 as weakest as alternative to Greenhill hardness test method to measure the hardness of the material. The weaker hardness test follows the Bring principle in that a tender on the definite shape is pressed into the material to be tested. The load is removed and the aggregate of the resultant reduction indication or are measured from this the hardness number calculated by dividing the load by the surface area of indentation, and the weakest test is easier than others hardness test since the required calculation are independent of the size of the inductor, and the intent can be used from all material representative of hardness. Alright, discussion. What is the HV value of diamond under Vickers hardness test? Alright, the value of diamond under Vickers hardness test is 10,000 HV. Alright. Second, what is the angle between the two surface of the diamond indicator used in the Vickers hardness test? Okay, the angle between the two face on the diamond indicator is 136 degree. The maximum distance to be maintained between in the indentation, the interaction between the work hardness region is the distance to be maintained between the indentation to avoid interaction is 2.5. What is the shape of the indentator used in the Vickers hardness test? Okay, the shape of indentator used is square base pyramid. Alright, see the similarity between hardness test and tensile test is the similar is but measure material resistant to press flow. Alright, see what is the of indentation on material use is material hardness test. The depth of indentation and the material use is 1/2 of diagonal length. Conclusion. Is this specimen the hardness of the specimen is determined by using a weaker hardness ratio for each reading. The hardness value are different, which are using cylinder aluminum brush and shade the difference between the hardness for this sample or statistically significant. Alright.
Saya Muhammad Alif Najmi bin Nazmi. Hari ini saya ingin mentangkan report tentang heat treatment of carbon steel. 1.0 objective to understand the purpose of heat treatment process. Number 2, to perform heat treatment process and explain carbon steel. 2.0 apparatus. Number 1, electric furnace, tongs, ladle, glove, tape pen. Number 2, specimen. Medium or high carbon steel. Mean by 1 cm by 0.8. Number 3, theory. Heat treatment is a method used to alter the mechanical properties of a material such as hardness and strength, using combination of controlled heating, soaking, and cooling. Various properties and the combination of them are the result without changing the composition of carbon steel. Transformation of phases will take place as this can be observed using metallographic approach. For example, heating a steel part beyond lower electrical point will transform its phase plane. Alright, cementite envelope temperature to right crystalline once the process temperature past the critical temperature. Continuous heating beyond upper critical temperature will transform the phase further the austenite. Rearrangement of grain of recrystallization will take place. Internal stress can be relieved. These are the examples of the effect of performing heat treatment that they are necessary to metal forming process. Heat treatment process on plain carbon steel. A. Full annealing. Purpose to soften metals preparing for upcoming machining process. Method: heat steel beyond upper critical temperature. Let it soak in such temperature for a certain duration. Quenching. Purpose: hardening steel by transforming steel from austenite to martensite. Method: heat steel within hardening temperature, cool steel rapidly into quenching media. Tempering. Purpose: to reduce the weakness of steel due to quenching. Hardness will be slightly reduced. Heat harden steel within tempering temperature. Number 4, procedure. Prepare 3 steel specimen of the sun ferrum carbon composition. Sample must have at least 2 flat opposing surface to provide for stable treating during hardness check. Label the sample for the sample of label right from the beginning until the end of experiment. Sample number 1 is the control sample in which no treatment to be applied. Sample number 2 will be quenched and tempered. Sample number 3 is for annealing. Using stable hardness number experimental setup, measure the hardness for all 3 samples. Take sample 2 and 3 into furnace, heat the sample beyond A2. Let furnace temperature stabilize for a few minutes. Take sample 2 out of furnace and quench into specified quenching media. Sample T is left heat beyond and let it soak in the temperature for 30 minutes. After 30 minutes, shut the furnace down and let it soak further. Before taking sample 3 out of furnace, make sure the furnace temperature will be below A1 to prevent hardening take place. Polish on surface for each sample 3 or 3 and remeasure their hardness. Document the data, finding and observation being made along the experiment. Ini adalah data initial reading. Bawah discussion. The quenching medium of natural air is medium cooling rate because the average initial reading is 49.86 and after reading is 46.08. Then the specimen when cooling process color using nature A is more than water because the specimen with using nature A must put in the water and then take it put to let it cool using nature A. The quenching medium of oil is using high cooling rate. Then the specimen cooling with oil is more heavier than water and natural water. The quenching medium of water is using slow cooling rate. Then the specimen weight is more lighter than oil and natural air. The color of this specimen is more a bit grey than natural air. Lastly, conclusion. This specimen was to conduct to know the difference in material properties of heat treatment of steel. There are three different quenching medium that being using, which is natural air, water, and oil to cool the carbon steel. There is a comparison between the cooling rate in different quenching medium and the hardness of the steel. It might show that cooling in water has more the carbon steel harder. This is because of the presence of high fraction of magnesite structure. The reading that we obtain fail to prove that the steel has the harder when put in the water compared to natural air and oil due to same mass during the experiment. Reference video from CDOS. So, kena dasarkan CDOS lah video. Okey, terima kasih.
Okey, kami bertiga akan membentangkan lab report 4 test on metal surface. Okey, bermula dari saya Muhammad Akmal bin Ismail. Okey, objektif to perform liquid present test on metal surface. Right, second, dia permanent kit consists of cleaner, and developer. Two different metal component of different turning treatment process.
Different forming treatment process.
Right, theory, liquid penetrant testing is one of the oldest and complex NDT method where is trials vision using and all mixture that back to the 19th century. This method is used to reveal surface observation by base dot of color of pressure dye from the law. The technique is based on the ability of a liquid to be run into a clear surface distinctly by capillary action after a period of time called the well time is a surface penetrant the remove, and the developer applied this as a blatter that draw the person from the naturality to reveal in presence. The advantage that a liquid resistant expression after another visual inspection is that it is make defect easier to see for the inspector where that is done in two ways. Alright. It product a flow medication that is more larger and easier for the eye to detect than the flow itself. Many flow are the small or narrow that they delivered by other side. A process with the previous is cannot resolve features smaller than 0.08 mm. It's improved the detectability is a flaw due the high level of interest between in the indication and background, which have to make the indication very easily seen. Much accelerate education on a white background for a variable penetrant, a penetrant that glows under ultraviolet light for fluorescent penetrant. Alright, liquid pressure testing is one the most widely used MOT method is probability can be attributed to main factor is relative case of velocity. It can use to inspect a mass of material or almost any material, provide there is surface in extremely porous material. The are commonly expected using the method include metal, glass, many ceramic material, rubber, and plastic. However, liquid penetrant testing can only be used to inspect for flaw that where the surface on the sample surface crack, porosity, lapse, seen lock or function, and etc.
Lab. Lab. Uh, 4.0 procedure. The general step can be summarized as follow. Number 1, surface preparation. Wipe the test surface clean from oil, grease, water or water combination that may prevent penetrate from entering flow. Number 2, penetrate application. Once the surface has been thoroughly cleaned and dried, the penetrate material is applied by spray onto surface. Number 3, penetrate the wheel. The penetrate is left of the surface for a sufficient time to allow as much penetrate as possible to be drawn from or to seep into this direct. Number 4, excess penetrate removal. Remove excess penetrate from the surface of the sample while removing as little penetrate as possible from the feed. Number 5, developer application. Apply a thin layer of developer to draw penetrate rampant inflow back to the surface where it will be visible. Number 6, indication development. The developer is allowed to stand on the part surface for a period of time, surface to permit the extraction of the trap penetrate out of any surface flow. This development time is essentially a minimum of 10 minutes. Significantly larger time may be necessary for tight crack. 7. Inspection. Perform visual inspection under appropriate lighting to detect decation from any flaw which may be present. Number 8. Clean surface. The final step is the process is to clean the part surface to remove the developer from the part that we found to be acceptable.
Number 6, result and estimation. In the experiment, we can spot the crack using this method and we can cover the crack using developer to make the surface clean and don't have any cracks. Number 7, discussion. This experiment have been applied in our industry because liquid penetrant test is to make sure the wet surface clear for any cracks and it avoid from being corrosion or cracks. Number 8, conclusion. In this experiment, we are able to spot the right dot since the developer liquid was applied so that the penetrating liquid would energy from the effort part. Menai reference video from CDOS. 10 precaution. Always work in a well-ventilated area. Number 2, observe a good housekeeping practice. Work area should be kept clean and filthy at all times. Number 3, alert and process with caution at all times in the laboratory. Notify the instruction immediately of any unsafe condition you observe. Terima kasih.